thank you so much for coming to my talk, everybody. I am going to be talking about getting started with GraphQL, specifically in an enterprise. In this talk, we're going to be talking about why GraphQL. I will be talking about our story of adoption of GraphQL from a PayPal's lens. I work at PayPal, and we adopted GraphQL there. So I'm going to be talking about why we decided to use GraphQL, what were the challenges we were trying to solve, our story of adopting GraphQL in the enterprise, and what were some mistakes we did, how you can learn from it, and if you are interested in getting started with GraphQL, how you can get started. Before that, I want to introduce myself. My name is Shruti Kapoor. I am a senior software engineer at PayPal. You can find me on Twitter at ShrutiKapoor08 or live streaming on Twitch at twitch.tv Shruti Kapoor. And if you're looking for somebody to work on your side project with you, you can come to the co-working sessions on Twitch. If you've been following me on Twitter, you know that I love dev jokes. So I'm going to ask you a question, 3 questions, and basically you can yell the answer out. So the first question is, why did the computer keep sneezing? It got a bug. Somebody else said something. I said virus. You're right. It had a virus. Okay, next question. What did the proud React parent say to its kid? Props. I've got to give you props. Okay, why do NodeJS developers wear helmets? To secure headers. Okay, if you want to know more dev jokes, you can go to the GitHub repo. But let's get started with the GraphQL talk. I know I'm standing between you and your food, so I'm going to try to make this short. How many of you have worked with GraphQL? Okay, and how many of you have never worked with GraphQL, never used GraphQL? Cool, awesome. There will be something for everybody in this talk then. So when I started using GraphQL at PayPal, I actually had never used GraphQL before. I thought it was kind of like this API thing, but it used to work with Gatsby, so I thought it was like something to do with Gatsby. I know Facebook made it, so I thought maybe it has something to do with like data type graph. My role in PayPal was, when I started, was to work on an application, and the application was supposed to consume an API, which was a new API that we were building. The application was consuming some REST API, downstream REST APIs that already exist in the enterprise, and the application I was building was a NodeJS app. In 2018, when I started working at PayPal, one of the main apps that was using GraphQL was Checkout app. Has anybody used PayPal Checkout? Awesome. So the app that powers PayPal Checkout is built with GraphQL API. In 2018, the support of GraphQL at PayPal was very limited. We did not have any internal tools, any central support. Every team was kind of building GraphQL on their own, so we're kind of venturing in the wild. In the community itself, GraphQL was slowly picking up. There was very little community adoption. But since then, a lot has changed. And if you look at the number of companies that have adopted GraphQL today and are using it in production, it's crazy. You can see all of the big companies are using GraphQL now. GraphQL landscape looks a lot different. We have GraphQL Foundation, which actually helps in maintaining GraphQL. GraphQL is an open source repo. And it is powered by different languages. So GraphQL is actually a specification, and you can implement GraphQL in any language you wish. GraphQL.js is an open source repo, which you can find here. But as you can see, there's a lot of people who are using it in production. And in 2020 survey, it was found that GraphQL is the technology that a lot of people are interested in. So if you want to learn GraphQL, this is actually a really great time to learn GraphQL. In the company itself, at PayPal, we are using GraphQL heavily. We have almost 50 apps that are using GraphQL in production. We also have a public API that is built by Braintree, one of our subsidiaries, that is also in GraphQL. And in our internal Slack community, we have over 500 members. Since 2018, we also built a lot of internal tools to help adoption of GraphQL in the company itself. We provided infra support to set up your GraphQL apps. We provided training materials. Now it's basically the default pattern for building any new NodeJS app. And we are using it all across the board in all of our subsidiaries. But if you're sitting in the crowd thinking, what the heck is this GraphQL? Don't worry. Here's a GraphQL 101. So what does GraphQL mean? GraphQL, if you break down the name, it actually, graph means the graph type data structure. And QL means anything to fetch the API. So it's a query language for fetching the APIs. So by graph, it is, you can think of your data's connection with different types of fields. So let's say you're building a library app. You have books, you have authors, you have titles. Title could be a string. So graph would represent how does a book connect with authors, titles, string, so on. So you're thinking of like the representation of data as a graph. So basically, GraphQL is a query language for APIs. And in fact, the definition of GraphQL is also that it's a query language for APIs and provides a runtime for fulfilling those queries. GraphQL is a specification. GraphQL provides a complete and understandable description of the data in your API and gives clients the power to ask for exactly what they need and nothing more. And I think that is actually a really powerful statement, that GraphQL gives clients the power to ask for exactly what they need and nothing more. I think that's also one of the biggest selling point of GraphQL, because it allows a UI or an application to ask for exactly the data they want, and they will not get any extraneous data. So if you think about how GraphQL works in comparison with REST, here's an example. Let's say that I'm building a homepage for PayPal.com. What I want to display is maybe the username, maybe their payment details, maybe how much money they have in their account, and maybe I want to show some notifications. So with REST, what I would have to do is, let's say that customer's account is the API I need to fetch for their maybe like payment details. There's a bunch of things that this account API would probably ask for, right? It could be the authorization, it could be the user ID, it may even internally call account details. And so what happens is, when you resolve one, maybe let's say auth came back and that gave you the ID. So you pass it down to other APIs. When they resolve, you get the whole object back, and that's when your entire endpoint resolves as well. And that's when you get the whole structure of the data that you needed. So there may be some fields like ID and token that the API requires, but you have no idea where to get it. So you have to go and explore the rest of the documentation, find which endpoints to call. Now with GraphQL, what happens is, let's say that with GraphQL, you only have one endpoint, the /GraphQL endpoint. All of the documentation would be here. Any of the IDs that you need would be here. So with PayPal.com/GraphQL, you'll send your request. And once it comes back, that's it. There's only one request that comes back. So the data is resolved right away. There's a few terminologies in GraphQL, so I'll talk about those. Four main things that we'll talk about today is schema, queries, mutations, and resolvers. What is schema? Schema is actually a full description of everything that your API allows you. So it describes completely the set of possible data type you can pass to the query, you can pass to the service. So let's say that I have a character type. It could have a name, it could have an episode. So this is how I'm defining my schema. So I'm saying I have a type character, and I may have a type starship. And then when I want to fetch something from the API, it's called a query. So I'm querying the API. The query kind of looks like this. So you'll have a query keyword at the top. And then here in the next lines, you're defining which field you want. So you're saying that I want hero, but out of that, I only want the name. And then I want the droid, and then let's say, this is Star Wars thing, so let's say that the droid's ID is 2000, a specific droid is what I want, and for that, I just want the name. So when you send this request to your service, you get exactly the data you asked for. So you get the name, and then you get the ID you get the specific name of that specific ID. So query, if you think about in terms of REST, it is kind of similar to get in REST. And the next thing is mutation, which is kind of similar to post and delete. So with the help of query, you saw we could fetch fields. With the help of mutation, you can also post or delete data from the API. Every field comes with a resolver. You can define a function that helps to resolve that data or helps to send back exactly what you ask for or do other sorts of operations or call downstream APIs. All of that logic sits in a resolver. Every field is given a resolver, so if you do not define a resolver, it's given to you automatically out of the box. So let's take a look here. Let's say that this is the query I have. This is the schema I have. So I've got a user, I've got given name, family name, and addresses. I can define the resolvers like this. So this is basically just JavaScript functions. I'll define everything for the user, the given name, family name, and I can do any sorts of filters that I want. So here, if you see given name and family name, this would be automatically given to you by GraphQL.js. So basically, in a nutshell, GraphQL is an open source specification. The main selling point is that it lets you ask for exactly the data that you want and gives you exactly the same data. And you can define the shape and the structure of the data that you want. And so that helps in actually reducing the amount of parsing you have to do on your UI. Another really cool thing about GraphQL is that because there is just one endpoint /GraphQL, there is no versioning. And if you need to add anything to the API, you can actually just add it to your schema. So like here on the left side, you'll see if you wanted to remove something, we'll add maybe like a directive next to it called deprecated. If you want to add a field, we can just simply add it to our schema. So there is no versioning. Now, schema is actually one of the main important things of GraphQL because it's kind of a contract between client and server. This is everything that a client can ask for from the server, so that's why schemas need to be established in the first, as a first thought. Well, one of the really cool things of GraphQL is actually the developer tooling that comes around with it. So at PayPal, why did we choose GraphQL? Well, we were having a few challenges at the time when we decided to move to GraphQL. Before diving into GraphQL, we thought of the architectural challenges we were having, and these are some of those challenges. So we had a lot of REST APIs and a lot of downstream APIs in our application, and what we noticed was that we may call an API, like account details, but let's say we only needed the name. But the API would send us back like 20 other fields, which we'd have to then throw away. So we had all this like waste data that we were getting from the client. We didn't have a way to like reduce the amount of data we could get. Another problem that we had, like I showed in the REST example, was we were doing multiple round trips. So maybe we needed an ID, maybe we needed a token. So we had to find like which API I need to call and then make a call to that and then come back and call my other API. So this makes it very slow to develop an application, but also just calling those APIs. Another problem was because we had so many different versions out in the wild, it was hard for us to know if clients were using the most updated version or if we could deprecate a field and nobody would get impacted. Sometimes some clients would be locked down to a single version, so they wouldn't get the updates because they wouldn't want to integrate again. Another problem internally as well was our APIs look kind of different from one subsidiary to another subsidiary. Also within the same company itself, within PayPal itself, we had so many different names. Something would be called like a username somewhere, something would be called like a user, something would be called an ID, something would be called token. So it was kind of very difficult to understand like which field goes where. The developer experience itself and the integration itself was very inconsistent. So when we were looking for a right candidate, some of the things that we wanted the candidate to provide us was, number one, uniform experience. We wanted that every client who was integrating with this API should see the same documentation, should have the same ID, the same names of each fields. Another thing was because we were developing these APIs for multiple subsidiaries like Braintree and Honey, we also wanted to make sure that it was easy for anybody who wanted to adopt this API to get started immediately. They shouldn't have to know anything in the background. They shouldn't have to know any of the enterprise knowledge. They shouldn't have to know about which API to call before this API. We wanted this to be like the source of truth. So it was very important for us that this API made it easy for clients to integrate with this API across the board. Another very important thing for us was because we didn't know which client with REST, we didn't know which client was using which field, or if we could deprecate it, or if we need to add anything. We wanted to make sure that this new API would have detailed analytics over exactly which field is being used, what kind of data people are asking for. And that's why I think GraphQL is really cool, because if you remember, we saw resolver. So every field comes with a single resolver. So we can know how many times a field has been called. And if a field has not been called, we can add deprecator to it and let our clients know that this would be going away. So we can intelligently deprecate and add fields. So when we were developing application, one of the common conversations we had around with our backend and front-end engineers was, let's say that we had a new request come in or a new user story come in, and we had to add maybe a new data to our API endpoint. Because we had versioned APIs, we were thinking like, how can I make it work with a versioned API? Should I add a V2 to this API? But the problem with adding that is it could be a breaking change. So if a client who's integrated with V1 now moved to V2, how would that impact them? We didn't know which field they're using, so we didn't know if it could impact them or not. Another thing was, if we do add V2, what happens to the clients who are integrated with V1? They don't get the new updates, so they're going to miss out on the new features. And we can't force clients to update their APIs. We can't force them to reintegrate with PayPal. Another thing we thought was, well, what if I can add query params to the same endpoint? Let's say I need to ask for more data. I could add new query params. That works when you have one or two query params you need to add. But what if you have to add like multiple parameters? Then you're basically polluting your query parameters. What if you add it to existing endpoint? Now you're impacting all of the clients that are integrated with it. So that's where GraphQL kind of comes in, and that's how it helped us. So the biggest points that it helped us with was, there's one endpoint. So if you're integrated with GraphQL, even if you don't want the newest update, you can still be on the current version and you can still get whatever you need. But if you want the updates, it's out there, you just need to fetch it, you just need to query it, just need to do a mutation. Because we don't have any more version APIs, we don't need to worry about whether our clients are outdated. They can get the new data if they want, whenever they want it. It was also really easy for us to intelligently add new fields or deprecate fields that were no longer being used. And as a client, as a front-end developer, one of the cool things that I really enjoyed was I didn't have to throw away any of the data I was getting back from the API anymore, because the API was giving me exactly the fields that I asked for. And so I didn't have to do any sort of parsing on my application. And that really helped us in one of our applications, because we didn't have to do any sort of like parsing or restructuring of the data, we were able to get rid of Redux even. As a developer, GraphQL was really cool. Anytime we showed GraphQL to folks, which is actually an exploration tool of GraphQL, people were like, oh my God, this is so cool. Because with that tool, you can see the documentation, and you can see exactly what the documentation, exactly what the query is, exactly what the mutation is, all of the fields that API is asking for, and you can also fire requests right away. So it's kind of like inbuilt playground with GraphQL, which was really cool. People really loved that. And it's also really awesome because if I do need to fire a different mutation, the documentation is right there. I don't need to look up any other application. So it's wherever, it's kind of like having Postman built in. It was also really cool because we have to think about schema up front when we build our application. So that basically meant that our front-end developers and back-end developers now started collaborating with each other in the beginning of the project itself. No longer were we building our APIs in isolation. No longer were back-end developers sitting on their own side and just working on their application, on their Java application, on the REST APIs, and then sending it out to the front-end. And then we wouldn't have to work with mock data anymore. So what was really cool was that front-end developers and back-end developers sat down together, established a contract was schema, and then we kind of went separately and independently worked on it. So it increased the collaboration we had in our teams. And so when we showed it to our developers, they were really, really excited about it, because now we had one endpoint. We can push out our updates as soon as we want. We have field-level instrumentation. We can deprecate and add fields intelligently. And we've got an established schema that brought our teams together. Now, there's a few different approaches of adopting GraphQL, especially in an enterprise that already has existing downstream REST services. I'm going to talk about 3 approaches here. So the first approach is to have a GraphQL wrapper over REST APIs. Kind of looks like this. So let's say that this is your client app, and it currently calls 3 different REST APIs. Let's say we're building PayPal.com homepage. So what you can do is you can have a GraphQL wrapper in between your client app and your REST app. So GraphQL is the one that is going to resolve all of the fields, all of the queries and mutations. And then GraphQL can do the job of figuring out which API to call. So basically, you can convert everything to GraphQL. Another approach is that you can have a REST wrapper over a GraphQL API. And this is specifically useful for clients that are tied to REST APIs that do not want to change their integration. So this way, what you can do is you can still have a GraphQL API internally, but you're surfacing a REST API on top of it. And GitHub does this as well. So you have a REST API that's surfaced to your client. Client doesn't see GraphQL API. They don't have to reintegrate. But internally, you can develop your GraphQL API. And another approach is that you kind of have to do duplication of work in this. It's not an ideal approach. So but what you can do is you can have your GraphQL API and your REST API coexist. And this works really good for systems that are kind of on a legacy system for one application, so maybe the REST API side, and then everything new is built on GraphQL API. So now let's start talking about how we started fitting GraphQL in our application in PayPal. We had a few different options of adding GraphQL in our applications. We did have new APIs that we were building. So we thought like there could be 2 approaches. One is we could orchestrate our existing APIs, convert them into GraphQL APIs, and let our clients talk to GraphQL. Another approach was that we could build anything that's new in GraphQL, and so build standalone APIs in GraphQL. Before we figured out and before we started plugging in GraphQL, there's a few things we wanted to know just to make sure. So one of the biggest things was how many clients are using the API. If we do orchestrate an API, it was really important that the impact was low, so we wanted to make sure that we are not using a high traffic API. Another thing was how many downstream APIs are we calling? And this was really important, especially if you wanted to orchestrate, because if your application is only calling one REST API, then you're not really using GraphQL's advantages. Then there's no advantage of converting your REST API to GraphQL API, because you're going to basically do a one-to-one mapping. Another thing was, what is the business impact? Can we reduce the amount of payload that we are sending? If we do convert this GraphQL API into a REST API, what application does it impact? If it's an internal application, it's a lot easier to convert or to take that time to do this migration from REST to GraphQL, because there's a lot of onboarding and learning involved for the team as well. And who are the stakeholders? Are the stakeholders people who use REST, so GraphQL would not work with them, or are the stakeholders internal developers and they are eager to learn GraphQL? And what is the time frame? So the app that we ended up choosing, the one app that I worked on was actually an internal tool. And one of the main goals we had for this app was to make it fast. And that's why GraphQL was really cool here, because we weren't sending a lot of data. We were only sending the data that the GraphQL client was asking for, and we had less code. So like I said, because we were not parsing data on our client side, we were able to get rid of some of the third-party libraries that were doing some parsing for us or state management for us. So because we were sending less data, there was less data to manage, and there was less code on the client. So what we did with this first app is we owned the backend REST API. So the REST API was also being built in parallel. It was a brand new API. So our GraphQL API was a completely plain orchestration layer. It did not have any backend. It did not have any business logic in it. All of the business logic lived in our REST API. We do have existing authentication APIs in PayPal, so we were able to use the existing REST APIs for that. And so what we did was our GraphQL layer was basically just like a thin layer, kind of like a proxy to call the rest of the downstream service. And the major one we were using was a REST API. So we found that GraphQL shines as an orchestration layer. If your REST API is sending too much data, if you can put a GraphQL layer in front of it, you're able to reduce that payload a lot. And so that's what we ended up doing. So the architecture kind of looked like this. So this is a client app which talked to the GraphQL API, which was purely an orchestration layer. It called the authentication and then called the REST API for business logic. So all of our business logic lived in the REST API, which then in turn called a bunch of other APIs. This REST API was brand new, was being built at the same time as the GraphQL API. This brought our teams together because we both talked about what API, what the schema would look like, what the UI would drive. And actually the GraphQL contract, the schema was derived by the UI's needs. So it was really cool because our UI was powering what fields the GraphQL should have. So it was a UI first approach. So what we ended up doing was we wrapped our REST API with the GraphQL API. The client sees and reaps the benefit of GraphQL. What was really important to that team was also that they did not want to implement a GraphQL API. They weren't completely sold on GraphQL. So this way, by having that REST API layer, they didn't have, the backend developers didn't have to change the way they were working. So everybody was happy. So basically, to summarize, this app, we created a GraphQL interface to orchestrate that brand new REST API. We delivered the data that our client asked for. The client drove what goes in the schema. It made it easier to evolve the API over time because our REST API was the one that held our business logic. Another very common approach that we have in the company is that any new logic lives in GraphQL API. And our checkout API, our checkout app is kind of like this. So the GraphQL API is the mastermind here and does the job of calling any downstream API it needs to do. One of the cool things about this is that if your REST API is sending a lot of data, this is where GraphQL can really shine because now you don't need to send, you don't have like that one-to-one mapping of REST API with GraphQL API, so you only send the data that your client is asking for. Currently, a lot of our applications are now defaulting to GraphQL, especially if they are powered by UI. Our mid-tier applications, which are the applications that sit between the client and the client's layer and the backend layer, they are starting to move to GraphQL as well. We are trying to move to GraphQL for our subsidiaries as well so that we can have this one layer, one GraphQL layer that all of our teams can integrate with. When we started moving, two biggest challenges that we had when we started adopting GraphQL was performance. And so GraphQL helped us with performance because our clients now determine what data they want, and we were able to deliver that data. But also they can also determine what shape of data they want, and that helps in reducing the size of the client-side app itself. Another big problem that we had was the dev productivity. It was really hard to find any API or the resource or documentation of our API, figure out which API to call next and where those parameters go. So with the help of GraphQL and the tools that it provides, it was really cool because now we could see and fire requests right away. And the explorability of docs was really cool because we had our documentation and kind of like our postman at the same place. So it was really cool to like fire requests, see documentation, fire our next mutation, and so on. And because we had really powerful instrumentation, really powerful field-level instrumentation, it made it really easy for us to evolve our APIs over time. So what we did was we established a schema contract, our UI drove the schema, and we started building our GraphQL APIs at the same time as our REST APIs. So there were a few mistakes that we did, but a few lessons that we learned as well, which helped us a lot in this GraphQL adoption. One of the first lessons that I can give away is to pick your first app and to ask yourself some of those questions that we did, which is, what is the business impact? Who are your clients? Who are the stakeholders? How much time do you have to build this application? And because GraphQL shines as an orchestration layer, even if you're not able to get the entire company on board, that's still okay because you can orchestrate one API at a time. So if your team really wants to adopt GraphQL, but the entire company is not sold, that's okay because you can slowly orchestrate your APIs. Another mistake that we made, which is a good lesson that we learned, is not to do a one-to-one mapping of REST and GraphQL. So by this, what I mean is, let's say that you have your REST API and your client needs to consume exactly every single field from that REST API. So basically, everything that's in the REST API will be in the schema, and the client will be asking for it. At that point, GraphQL is not a really good technology. It's not a really good use of GraphQL. You're going to have to basically duplicate your work. So don't use GraphQL for a one-to-one mapping if you have a REST API that needs to be consumed completely. And another cool thing is to build schema together. Because the UI can now drive the schema, it helped us a lot in bringing our teams closer, helped increase the developer productivity and collaboration between teams. And one cool thing, if you're not using TypeScript, is that GraphQL gives you type safety out of the box. So for us, it was really cool because we can now define in the query, in the contract, you have to define if a field is a string, is an integer, and so you get schema, you get type safety out of the box. But there's word of advice. GraphQL is not a magic thing. It won't solve all of your problems. Your API, GraphQL API, will be only as fast as your slowest endpoint. So if there is an API that takes too long, that's probably what you should address first instead of converting it to a GraphQL API. Another thing is that a lot of people don't realize that you'll have to think about the schema in advance. So if you are working on an application where you may not know upfront what kind of data the client may be asking for, GraphQL may not be the right fit because you have to develop that contract the first thing. There are still some challenges of GraphQL that the community is still working on. So if you have an application that deals heavily with caching or handling errors or parsing that error object to show a specific type of error, GraphQL may not be the right candidate for you because those things are still being developed. And like I said, you need to know the schema upfront. So maybe if you have something like a public API, where you don't know what kind of query, what kind of mutation the client could ask for, it will be very hard to build a GraphQL contract and a GraphQL schema that way. Another problem that we are specifically facing in our teams is that we have multiple teams that now have their own GraphQL endpoint. We're trying to move to a one graph approach, but that has been a challenge still, and we're still working on it. So working on a federated graph in an enterprise that big and getting everybody on board still is a challenge. So if you are interested in GraphQL, here are some next steps for you if you want to adopt them in your enterprise. First thing I would say is assess if GraphQL is the right fit for your architecture. So some of the questions you can ask yourself is, what are the challenges you have right now? Who are your consumers? What kind of data they use? How much data do they use? What kind of language they use? Are they tied to a REST API? Are you building a public API? Where are you going to put business logic? What about your authentications? Another thing is if you want to adopt it in your company, think about your company-specific things. So where are you going to put your analytics? What kind of analytics you have? Can you have field-level instrumentation? What about your monitoring? What about your authorization? Where are you going to put that? Do you need your schema or your queries to be tied down to a specific user or a specific permission? How are you going to implement that? So those things could be really helpful in understanding if GraphQL is the right fit for you. Another thing, like I was saying, is are you going to save any data by converting to GraphQL? So if your client is going to need to ask exactly the same fields that your REST APIs or your downstream APIs are doing, then you're basically not using GraphQL for its advantages. GraphQL doesn't really have a role to play there. Another thing I would say when you want to onboard your company and when you want to increase the scale at your company is how are you going to onboard new teams? How are you going to impart knowledge from one team to another, share that knowledge? How are you going to enforce standards? So type safety, schema definition, how are you going to merge multiple schemas together? So to get ready for your enterprise, I would say start with maybe a dog food exercise. Maybe think of one small app that could be useful as an orchestration layer that could be used to convert to GraphQL. Maybe work with your clients, maybe work with your front-end teams and the back-end teams, get them together in a room, see if GraphQL really fits well for you. And then once you want to start scaling it up, once you have kind of gotten that yes from your team, so set a standards team. And this team will help enable different APIs and different type safety for your GraphQL layers. One of the things you'll have to start thinking about is schema stitching, which is when two teams have their own schema and they want to use, like, let's say common fields, let's say like username. How are you going to have those two graphs merge together? So you'll have to think about those. So set a standards team that can help you kind of onboard this and make it easier for other teams to also adopt GraphQL within your company. Also, one of the biggest things about GraphQL is because it's open source, there's tons of open source libraries and tooling available. So maybe do a little bit of research of what existing tools can you use. So now, if you want to sell it to your team, here are some things that we focused on that kind of helped sell the story. We focused on dev productivity. That was one of the challenges we had. If we can get our developers on board and if we can solve their problems, it's a lot easier to convince leadership. So once we showed them the graphical tools, the playground tools, how easy it was to explore APIs and call APIs and add new fields, it made it a lot easier for people to be convinced about GraphQL. And focus on incremental adoption. Oftentimes, we think that the entire company has to move to GraphQL, but that's not the case. You can move to GraphQL one team at a time. So you can incrementally adopt your apps as GraphQL apps. Focus on the collaboration between teams. For us, this was a really big thing because our front-end developers and back-end developers, they were kind of working in isolation before, in silos before, and with the help of GraphQL, because we had to establish schema in the first place, it kind of forced everybody to be working together. Focus on the tooling that's out there. There's tons of open source libraries that help in the adoption of GraphQL. And one of the things that helped us was focusing on that there are no versions, so everybody is updated whenever they want to. And another cool thing is that because the data kind of looks similar to JSON, it's easy for new engineers and new developers to onboard onto GraphQL as well because it feels familiar. And one final thing I would say is that get your architects and your domain experts on board so that they can kind of help you find out, solve the problems of authorizations, of analytics, of monitoring. So get your engineers, get your architects on board as well so they can help you solve the business logic perspective of GraphQL. So there were a few questions that a lot of people had in mind when we were introducing GraphQL, and I think this may help you as well. Some common myths that are associated with GraphQL is that you need a graph type database, but you actually don't need a graph type database. Whatever you have right now would work. People think GraphQL is kind of similar to SQL, but it's actually a query language for your API, not your database. A big misconception is that it's only for front-end applications, it's only for JavaScript developers, but it's not. There's GraphQL in Java, Kotlin, Go. It's a specification, so you can build it in any language you want. A lot of people think that all of my services are in REST and nobody would want to move to GraphQL, which is okay. You can move to GraphQL one API at a time. You can start orchestrating. A lot of people think I have sensitive data, so it would be exposed to the entire public. But however you expose your data right now, that would still work with GraphQL. You just have to think about where it's going to fit in. But however you expose your data right now, that will still work. And another question people have is, can I limit what APIs are exposed? And you can totally limit what APIs are exposed. A lot of people think that GraphQL doesn't support auth, but you can fit in your authorization however you're doing right now. And a lot of people think that I don't want to expose my entire database, which same thing, you can limit whatever you want to do. It doesn't expose your database, it's just an API for calling the data. Okay, to wrap up, no technology is perfect. GraphQL is not perfect. It's not a magic wand that will solve all of your problems. But for the problems that we were having at PayPal, it was able to solve a lot of those problems. And so I would suggest when you want to adopt GraphQL, think about the challenges that you have and if GraphQL is the right fit for you. But I would also say that GraphQL is actually here to stay, and a lot of companies are starting to move to GraphQL. There's a lot more jobs in the community on GraphQL. So if you are interested in GraphQL, I would definitely give it a shot. And I would say get involved in the community. The power of GraphQL is the community that comes with it. And there's a lot of tooling in GraphQL that can help increase your productivity. We wrote another blog post on our PayPal Medium Tech, on our PayPal Medium blog, which is a success story of PayPal checkout application that you all may have seen. You may find that useful if you want to adopt GraphQL in your company. And I'll leave the slide up for just 1 second, which is some success stories of other companies that have adopted GraphQL. And I would highly recommend if you want to adopt GraphQL in your enterprise, Marc Andre's book, Production Ready GraphQL, it helps a lot. Finally, thank you so much. If you have any questions, please feel free to grab me around. I'll be here. Or you can send me a DM on Twitter. All of the slides will be available here. I will send a snapshot of today's talk in my newsletter as well, bit.ly/Shruti newsletter. Before I go, I want to leave one final dive joke. Thank you so much, everybody. You've been great.